Okay, hi everybody. Today we're going to watch this video and review cell membrane transport, which is what we've been talking about over the past week or two. So to do that, we're going to talk about simple diffusion, facilitated diffusion, and active transport. Okay, so we talked before about diffusion. Let's just talk about it again. We learned a little bit about this and we demonstrated it in class with the cologne. And you might remember, with diffusion, molecules go from a place where they're really concentrated, we call it an area of high concentration, to areas of low concentration. So they go from high concentration to low concentration. And they do this without the use of energy. There's no energy required. So there's no energy required in simple diffusion. This is just a natural process, and we experience it every day. So let's review quickly how the cell membrane is structured. First, we have these little things we call phospholipids. And phospholipids have a phosphate head. Okay, a phosphate head. And these are fatty, I know this is a funny word, fatty acid tail. Okay, so that's a structure of a phospholipid, and that's the main part of a cell membrane. Now the one thing about this, okay, so notice how it's structured like this. There's going to be two of them, two layers of phospholipids in the cell membrane. Kind of looks like this. I'm not the best artist in the world, but it sort of looks like this. And we call this a lipid or phospholipid by, oops, let's get to that. Undo. So sorry, by a layer. Okay, let me write that again. By layer. And this word by means two. Okay? So again, we've got our phospholipids that has a phosphate head and a fatty acid tail. And it's a lipid bilayer, meaning there's two layers. So again, just real quick, we talked about this, how we have our lipid bilayer here. This is our lipid bilayer, and these are our phospholipids. These guys right here are phospholipids. I'm just going to really quick put this here. And this, you might remember, what is it? It's a protein channel, and that helps big molecules get in and out. And this one down here, I'm just going to run it down here. This is our carbohydrate chain, and that's to identify, that's our identity. Okay, tells the rest of the organism who we are. Okay, so here we have again a picture of the membrane with the phospholipid bilayer, and there's a protein channel here. I'm just going to put this here as my protein channel. Protein channel. Now let's say we have a bunch of little oxygen molecules out here, and notice how concentrated they are. How do molecules move from areas of high to low? So where are the oxygen molecules more concentrated? They're high here and they're low here. So these are little enough molecules that they can easily just go through the membrane like this. And as a matter of fact, other small molecules might be able to do the same thing. So maybe we've got some water molecules here, and they can also kind of get through here. They need a little bit of help, but they can get through here fairly easily. So now we've got water molecules here, and we're also going to have our oxygen molecules here. So they're small molecules, and they can get through pretty easily. But what if we had a big molecule, let's say sugar molecules out here, and they were high concentrated? They would have to go through the protein channel. They're too big. Now, if there were more sugar molecules here than there are outside, how are they going to go now? Remember, we're going to go from high to low. So these sugar molecules in this case would move out this way. Okay? So we call this a diffusion of small molecules through the membrane, like that. We call this simple diffusion. And if we want to move large molecules, into the cell, okay, like this, they have to go through the door, and we call this facilitated diffusion. That's facilitated diffusion. And you might recognize this word. In Spanish, I know facil, I believe, is easy. So facilitated means to be made easy. And the door makes it easy for the large molecules to get through. Now let's say we had a situation like this, where we had more sugar molecules on the outside, so they were high, so we had a high concentration on the outside and a low concentration on the inside. Now normally, we would expect the molecules to go through the protein channel from high to low, like that, right? Through the protein channel. Let's say there's a protein channel here. We go from high to low. Let's say I want to get these molecules to go this way. How do I do that? In this case, this requires some energy. I'm pushing myself upstream. I have to go against the concentration gradient, we call this. It's like swimming upstream. It's like fighting through a crowd. And to do that, it requires some energy. We need ATP here to be able to move these molecules through against the crowd. So we require energy to do that, and we call this active transport. It's active because it requires action. It's not facilitated, it's not easy, it's active transport, and it requires ATP in order to do that. So that's our summary. So we've talked about simple diffusion, across the membrane, small molecules, no energy required. We've talked about facilitated, sometimes called passive transport, facilitated diffusion. These are large molecules. No energy required. Okay. Oops, ran out of room there. So that's those two. And then we talked about active transport. Okay, that's moving molecules from low to high concentration. And this one requires energy. Requires energy. So that's it. Next time we'll talk about osmosis.